All right, so learn goal 14. We're going to be looking at squares of non-natural numbers. And this is going to be kind of, again, it's similar to what we did in the last couple days, but it does deal with some different stuff as well. So let's start off with a bit of review. To solve a number which has been squared, okay, the number must be, or it will be, multiplied by itself. So kind of as an example, I'll go through an example later, but when we multiply something by itself, that means that we are squaring it. Okay? And the procedure to solve for, this is also the procedure to solve for the area of a square. So if we're trying to find the area of a square, we do the same thing. We multiply the side length by itself. Now, in the past lessons, the first 20 perfect squares have been used, and we're going to kind of continue using those 20 perfect squares as we go. Now, the lesson is going to look at decimal numbers, okay, which are between the square roots of the perfect squares. Okay, so it's going to be looking at decimal numbers, not at perfect squares. It's going to be looking at the decimal values of those perfect squares. So let's think back to what we've done in the past. 4 squared. Well, 4 squared is the same as saying 4 times 4. Okay? And 4 times 4 is 16. So that means that 16 is a perfect square. Okay, so 16 is a perfect square. And again, what we're doing with squaring things is just we're multiplying it by itself. All right, now a natural number, such as 4 is a natural number, should be able to be done without much practice. These are the ones that I've been wanting you to do in practice, those first 20, so 1 squared, 2 squared, 3 squared. Okay, but a number that's between those numbers, such as a decimal or decimals, okay, can also be squared without a calculator using our perfect squares. Okay, so we can use our perfect squares as benchmarks or as values so that we can evaluate or estimate the square of a certain number. Now again, as I've mentioned before, these are not going to be exact, but are going to be an estimation. Okay, so these are going to be an estimation of our answer. They will not be an exact value. Okay, and it's important to remember that it's that estimation. It's not exact. How are we going to do this? Okay, a 5-step process as to how we're going to do this. First thing that we're going to do, and so this is again looking at the number that's going to be squared, is we're going to select the natural numbers, or the natural number which is below and above the square. Okay, so the one that's below and above the square. So there will be one that will be right below and one that will be right above that we're going to use. Next, we're going to create a number line, and again we're going to use number lines. Number line, with the 2 natural numbers that we chose here being the ends. So one will be on the top and one will be on the bottom. Okay. And again, I'm going to do a little bit of practice with this as well. So we will do some practice with as well. We will do some examples. Okay. Then we show the squares on the other side of the number line, similar to when we did the square roots. We had the square roots on top, and then we did the roots underneath. Now we're going to do the squares on top or on the bottom, or the number on the bottom, and then we're going to do their square on the top. So, and again, like I said, I will go through this and I will do an example of this in just a little bit. We place the given square on the side with the natural numbers. So that'll be on the bottom. And then we're going to try to be as accurate. Let's change, there we go. As possible with our placement Okay, so we're going to try to be as accurate as possible with our placement. Next thing that we do, and I'm just going to change the color one more time here, is we estimate the square of our value. Okay, so in this case here, 4, we didn't need to do much estimation because that is a perfect square. 2.5, on the other hand, is not a perfect square. Okay, it's not a natural number. Oh, sorry, it's not a perfect square. It's not a natural number, which means that when we square it, we're going to get something between a perfect square. So let's take a look at how do we estimate or calculate 2.5 without the use of a calculator. Oops, I didn't want a triangle. I wanted a number line. All right, so we're going to put a line on here. We're going to make that into a number line. We're going to put arrows on either side. For your assignment, I'm going to be asking you to always write in or draw in a number line. For your weekly progress check, I will give you the number lines like you've seen on the screen here. So those ones will be as you see on screen. So how do we solve 2.5 squared without a calculator? Well, first things first, we're going to put 2.5 squared here on the bottom. And we need to come up with our two natural numbers, one that's below, one that's above the 2.5. So the one right below is going to be 2, and I'm going to write that in as 2 squared. And the one right above is our next natural number, which is 3 squared. So I'm going to put those at either end. Now 2.5 would be kind of right in between, so we're going to put it right in between, kind of right in at the halfway point. Now on the other side, and I'm going to use a different color for this, okay, 2 squared is 4, 3 squared is 9, and 2.5 is somewhere there in the middle. Okay, it's somewhere there in the middle. Now the values right between here, so if we want to take a look at these two, so it's going to be like right between, like right in the middle. Sorry, that's not straight. But if we're looking for the one that's right between, that would be the number 6.5. 6.5 is right in between 4 and 9. Okay? And we could use a whole number as well. We could use like 6 or 7, but that might not be quite as accurate. 6.5 is right in the middle. Okay? It's right in the middle, which means that, and 2.5 is right in the middle of 2 and 3. So that means that 6.5 is probably a pretty good estimation. Okay? It's probably a pretty good estimation. And we can kind of figure out, or we can use that. Another way that we can do it as trying to get as best an estimation as possible, or as close an estimation as possible, is think about the gap between 4 and 9. Okay? Between 4 to 9, there's a gap of 5. Okay? So there's a gap of 5. Now, because we're using one decimal place, let's think of it as tenths. If we divide, this is just one way to think of it, by 10, that's going to equal 0.5. Okay. This is a way of thinking about it. This is kind of the way sometimes my mind works a little bit. Sometimes it's helpful. Sometimes we just are estimating in general. But if we divide by 5 by 10, we get 0.5, which means that there would be 10 groups of 0.5 in between. If I do 5 of them, so if I do 5 groups of them, 5 times 5 is going to equal 2.5. So the answer will probably be 2.5 above 4. So 4, now this is kind of, it might be a little bit weird for some of you, is equal to 6.5. And so the answer will be, my estimate will be 6.5. It's just a way of trying to solve it, of trying to kind of think through that process. You can also kind of use a guess. 6.5 is right between. So we're going to try to use a guess and determine if that is in fact the case. Okay, so this is one way to think about it. This is just the way that sometimes my mind thinks through it, and the way that my mind relates it. So you can kind of like, take it for what it's worth, is what I would say. If that works for you, go for it. If not, don't worry about this and just try to do a nice estimation. All right, let's do a little bit more practice here. Let's try another one. 1.2 squared. So 1.2 squared is going to be somewhere in between. The numbers on either side, on this side, we're going to do 1 squared. And on this side here, 2 squared. Okay, there's going to be our benchmarks. I'm going to call those our benchmarks. 1 squared is here, 2 squared is over here. 1.2 is going to fit somewhere in between those two. And I would say it's probably right about here. It's pretty close to 1, not right on 1, but pretty close to 1. That would be my guess. And so it's probably, let's actually do a nice line here. It's probably right about there. Okay, that would be roughly where it is at. All right, on top, we have 1 squared is 1, 2 squared is 4, and somewhere in between is going to be 1.2. Now, if we think about, this is another way to think about it. If we think about our numbers here, I'm going to do this here. Okay, this is our number line. We have 1, 2, 3, 4 on top, and underneath we have our squares, right? So 1 squared, 2 squared, and then somewhere here we're going to have some decimals. 1.2 is kind of right between 1 and 2, pretty close. It maybe even a little bit closer to 1 than 2, depends on how close my estimations are. So my guess is that this is going to be somewhere around like 1.4 or 1.5. That would be my guess on my estimation. Okay, that's actually a really close estimation if we think of the actual value, but I would say that that's a pretty good estimation of 1.2. Okay, because it's between 1 and 2. I would say maybe a little bit closer to 1 than 2. You might say that it's closer to 2, depending on where you put your number. If you use my above method here, it would be about 1.6 even. So if you're 1.4 to 1.6, any one of those is going to work. Okay, so that's how we estimate. We put in our benchmarks, we put in our actual one, and then we put in the squares on top, our perfect squares, and then we try to estimate what that square is right there. Let's try 3.9. Now, you notice 3.9 is going to be really close to one side, just like 1.2 was. It'll be pretty close. So I'm going to put 3.9 squared here on the bottom. Okay, so it'll be somewhere there. The ones right below is 3 squared. And the one right above is 4 squared. Okay, so there's my natural numbers, and here is the one with the decimal. Now it's going to be probably like over here, and I'm going to draw a line there, right about there. That's where my 3.9 is going to go. Okay, it's really close to 4. All right, now on top, my perfect squares. 3 is 9, 4 is 16, and that means that 3.9 is going to be somewhere between 9 and 16, but probably really close to 16. And I'm going to put this in here. We could say it's 15 if we want to just leave it at that. Again, trying not to get too accurate. Or we could say that it is 15.5 even. Okay, we could say 15.5. That would work as well. Because it's really close to 16, we could say 15.5. The actual is kind of in between there, actually. But we can kind of use that as being a reference guide or as being an example. If we were to use my other method right here, we would actually do 15.3. There's a gap of 7. If we divide by 10, that means that there should be groupings of 0.7. If we do one grouping down, 16 minus 0.7 would be 15.3. So our estimation would be 15.3. And that will probably give us a pretty good estimate as to where it is. I'm going to show you this method on the last one because, well, I think the last one's probably the easiest one to see it on, or maybe the best one to see it on, or maybe the most helpful, I should say. But we're going to look at 14.2 squared. We're going to try to estimate where does this fit on our line. Right below 14 is, right below 14.2 is 14. Not sure why that worked that way. And right above is going to be 15 squared. Now 14.2, just like little glitchy there. Just like the previous one here is also a 0.2, so it's probably in about the same place. And if we use the drawing tool, I'm going to just put it, it's going to be right about there, roughly. Okay, it's going to be roughly right about there. Now 14 squared is the same as 196. And 15 squared is 225. Again, I'm going to do some of this stuff. Oops, sorry about that. I'm going to do some of this stuff really quickly. So it might be, again, this might be a little bit over your head. There's a gap of 29. And so I'm going to use groups of 3. Okay, I'm going to use groups of 3 because 29 divided by 10 is really close to 3. So I'm going to use groups of 3. Now, 14.2, okay, if we're thinking of tenths, there are 2 groups of 3. Okay, 2 groups of 3 is 6. So I'm going to estimate that my answer is 6 above 196. 2 groups of 3 above. So I'm going to guess that the answer to it is about 202. That's going to be my guess. That's going to be what I expect it to be. Maybe not. It might not be exact, but that is kind of where I would roughly expect it to be, approximately. Now, I think that answer, if I look at a calculator, it's actually really close. 202 is really close. It might be way off. It might be really close depending on what we do, but this is definitely a way to do that. Okay. Now, I'm just going to give you your assignment right here. The assignment is LG 0.14, questions 1 to 3.